This technology was funded by the United States Department of Agriculture to the Purdue University Center for Food Safety Engineering and the Purdue University Cytometry Laboratories. So here's the big question. If you could identify every colony on every plate without spending 1 red cent on reagents, don't you think this might be a good idea? So what is this technology? It's called elastic light scatter, and here's the principle. First you have a laser, not a monster powerhouse, just an ordinary laser, like a laser pointer. You need a camera, some robotics, and some really smart software. You fire the laser at each colony, you know exactly where they are because the camera plate image calculated the exact coordinates of each colony. Actually, each colony has a number, so when you produce scatter patterns from each colony, you know exactly which one that scatter pattern comes from. It only takes 1 second to evaluate each colony. So that's about a minute for 60 colonies per plate. And by the way, you can look at every colony, not just the ones you think might be interesting, so you don't miss nasty organisms because you didn't check them. The powerful thing about this technology is that once you collect a pattern from a colony, you can immediately compare it with a database of collected signatures. The database is one of the most powerful aspects of this technology. The details of every colony collected are automatically entered into the database, and from that database we can retrieve any data set you want, and within that data set every colony pattern recorded. In fact, even without opening the dataset, you can preview all the colonies if you want. But that's not all. On the left side of the database screen are listed all the existing classifications that are in the database. As you can see in the lower panel, this database already has dozens of classifiers for Salmonella cerevars. These are fingerprints embedded in this database so that any colony that appears on any plate with the same fingerprint as held in that database, that identity will be instant and accurate. The success of light scatter technology is not so much in the hardware as it is in the software. First, a powerful calibration technology is embedded that ensures that the hardware does the very best job in finding and collecting reproducible light scatter signatures from a dish. Then there are feature selection tools, Zernike moments, Haralick texture, and Fourier transforms that are used to define the types of features used. A clever tool for memory management exists when a very large number of patterns must be analyzed, and the unique technology created for time course analysis where each colony on a plate that is analyzed over hours or even days can be followed precisely and directly compared with thousands of other colonies in a few seconds. Then there are some very special features we recently developed. In fact, they were developed in response to some of our users who asked us to solve a couple of simple problems. The first was that sometimes colony patterns were too bright or too dim because of the variable density of the colony. Could we create an algorithm where a range of intensity was collected on all colonies if desired? We call that HDR, or high dynamic range, and it helps extract that underlying pattern when the laser overexposes a colony pattern. Also, what if you just wanted to know how many different groups of colonies there were on a plate? Could you create an algorithm that would help answer that question? We did, and we called it colony differentiator. Here's how it works. It can use any feature for selection. So, for example, colony size could be one differentiator. In this case, we chose 3 different colony sizes, and the results of the analysis was a map showing which colonies fitted each group. You can see them colored in 3 different colors in this screen grab from the analysis software. So now you can see the original plate showing all the colonies. Then the final cluster differentiated plate with 3 groups identified. If you wish, you can see each of the clusters, and you can identify each colony in each cluster by its unique number. The process for selection is complicated but user-friendly and uses a combination of different feature selection processes. There is an almost unlimited capacity for analysis using this technology. Finally, this technology is incredibly powerful. It can identify even the most difficult organisms totally in the absence of any reagents with high accuracy and can operate with a variety of media types from different companies. When you combine this with the advanced analytical software developed by our group, this reagent-free technology reduces cost, increases accuracy, and provides a vast array of valuable information for microbiologists across many different fields of interest. Light scatter technology has opened up a new technology for low-cost discovery in microbiology.